So now that we derived the quadratic formula, let's go ahead and use the quadratic formula. Okay, so here we go. This one, x squared minus 8x. So first, before you solve any equation, bring everything to the same side and set it equal to 0. Let this be like a habit, right? Because it's also important later on. So now, x is negative b is 8 plus or minus the square root of b squared is 64 minus 4 times a times negative 33 all over 2 times 1, which is 2. So x is 8 plus or minus, this will be root 244 all over 2.
Wait, how would it be?
So we did it with a calculator and it works. So as a matter of fact, why don't you guys have your calculators out on your desk so you can, go ahead and plug this in with me. Now, 244 right? Now look. A number like 244, you should be able to simplify without a calculator, right? Because this is 122, 2, how much? 66? No.
64. Yeah, that makes 66. Wait.
No.
61.
61. It's 61. Sorry. It's 61.
Isn't it root 196?
Yeah, 196.
Yeah, because it's 4 times 33 is 132.
Oh, is it 196?
Yeah.
Okay, so what will 196 be?
196.
Yeah, it is.
Oh, so that's the square root of 16, right?
Is it 14? No, it's 14.
No, it's 14. Sorry. So this is 8 plus or minus 14 over 2. So look, before I even simplify, I can divide both of these by 2, right? So this is 4 plus or minus 7. So x is 11 and negative 3. Okay?
Wait, 14 is a square root?
Right. So let's do this next one. So x equals negative 6 plus or minus the square root b squared 36 minus 4 times negative 16 all over 2. So x equals negative 6 plus or minus, what do we get inside the root? 100 over 2. So that's negative 6 plus or minus 10 over 2. Correct. So x is 2, negative 8. Okay? All right. Okay, so this one, x is 16 plus or minus the square root of 16 squared, you should all know. How much is it?
16
squared.
256.
That's right. Minus 4 times 64 all over 2. Okay, and what's 4 times 64? Right, so this is just root 0 over 2, so this is just 8. Okay? Here, x equals 4 plus or minus the square root of 16 minus 4 times 13 all over 2. 4 plus or minus, what do I get in the square root?
52. No. Yeah.
Negative 52.
Negative 36 over 2. So this is x equals 4 plus or minus what? 6i over 2. 2 plus or minus 3i, that's the answer. You can, okay, so look, let me have eyes up here for a minute. Eyes up here. Here I have a 4, I have a 6, I have a 2. If 1, 2, 3, all three of those numbers are divisible by the same number, then you've got to simplify. Divide this by 2, divide this by 2, divide this by 2. However, if I had, for example, 4 plus or minus 5i over 2, can I simplify the 4 into 2? Oh, no, no, no. You know what that'll make me do? Like when I'm grading, that's the sort of thing that makes me like flip back to the first page to see like which student did this. Because by Algebra 2 Honors, we should know if two things are being, you know, added or subtracted, you can't just cancel one thing, okay? Yeah.
Wait, but why couldn't you do like, because isn't that the same as 4 over 2 plus or minus 6i over 2?
Right, but then that also has to be simplified to 2
Right, but
plus-
pretend it was like something like 7i over 2 and 4 over 2. Why can't you do 2 plus or minus 6i over?
Okay, you can do that.
Oh, okay.
That you have to do, but you can't just cancel one thing and not the other, is what I'm saying. Okay, so let's clarify that. If you have 2 plus or minus 5i over 2. Sometimes like a student will be like, oh, okay, and that's just 1 plus or minus 5i. No, that's wrong. This is wrong. But if you did 1 plus or minus 5 over 2i, this is correct.
Okay.
Okay, that's what I was saying. Okay, this next one, E, is actually the same one as D, so let's just skip it. Okay. Okay, this one. Okay, negative 25 plus or minus, what's 25 squared? 625. Plus or minus the square root of 4 times 2 times 33 all over, oh no, it's just, I don't know, minus over 2 times 2. The best way to make students participate is if like I make a mistake. Then like everybody is like, you can hear everybody's voice, but like when I ask a question, nobody wants to participate. Okay, so negative 25 plus or minus, what do I get in the root? 361. What is that? That's 19. That one you don't have to know by heart. Plus or minus 19.
For a question like this, would we get a calculator?
Yeah. So remember how I was saying the other day, you should know all of the perfect squares until 16 squared. Or like 19 squared, you don't have to know. So this one, this is how we leave it, right? Oh no, I'm sorry, this is not how we leave it. So when you simplify, what do we get? Negative 11. And also negative 3 over 2.
Wait, wouldn't it be positive 11? Why is it negative? Because they're both.
They're both negative, right? So the negative one, negative will be negative, and then even if you add, negative 25 is higher than positive 19. No. So these are both going to be negative. Because when you negative 25 minus 19 is negative, negative 25 plus 19 is still negative. Yeah. Okay, so x equals negative 5 plus or minus the square root of 25 minus 4 times 3 times 4 all over 6. So how much is in the root now?
25 minus plus 48.
Minus. Negative 23 over 6.
So would you just take out I?
Correct. We take out the I, negative 5 plus or minus I root 23 over 6. But now we got to split this up, real and imaginary part. So x equals negative 5 over 6 plus or minus I root 23 over 6, right? Split up real and imaginary, and you get a when you get a complex number like this. Okay, last but not least, x equals positive 8 plus or minus the square root of 64 minus 4 times 9 over 2, right? So this is 8 plus or minus root how much? 28 over 2. So the 28 you should be able to simplify. Correct. And if you can't just think of it off the top of your head, do a factor tree. And these are the leaves of the factor tree. Imagine the root 28 is in jail, right? So all these numbers are in jail. Whatever can find a pair can come out of jail, but you know, as a single 2. And then that poor 7 doesn't have a pair, stays in there. Okay? So what is this simplified?
4 plus or minus 2 root 7 over 2.
Which is root 7.
Oh.
Okay? Yeah, you have to simplify it all the way. So, before we move on to the next page, take a look at what we did here. Here, so take a look. In my root, right, I have a positive number, right? And what do my solutions look like? I have 2 real solutions. Here in my root, I have a 0. And what do I have? 1, 0, which is also real, right? Here in the root, I have a negative number. So my solutions are, how many solutions do I have? 2, and they're imaginary or complex, right? So then the number inside the radical is what, you know, can tell you how many and what type of solutions you're going to have. That number inside the radical, the filling of the radical, is called the discriminant. Okay? So the discriminant is just b squared minus 4ac. That's it. No root, just b squared minus 4ac. And if that number, b squared minus 4ac, is positive, then we get 2 real roots. Okay? So now, take a look at this one and this one. In both of them, b squared minus 4ac is positive and positive. So for both of these, we're going to get 2 real roots. But if, in addition to being positive, if it's also a perfect square, then we get 2 real rational roots. Yeah, I'll fix that. So here, if the discriminant is positive, but it's not a perfect square, then I get 2 real irrational roots. And this should look like this. Okay. I copied this over there. Okay. Now, when the discriminant is equal to 0, I get 1 real rational root. When the discriminant is negative, I get 2 complex roots. Okay, so a couple of things. Gosh, so much to tell you. So first of all, you are seeing how the imaginary numbers, right, the complex numbers are always coming from the root. So it's always plus or minus. When you get complex solutions to an equation, it doesn't matter if it's quadratic, cubic, doesn't matter. When you get complex solutions to an equation, they always have to come in pairs. You can never get 3 complex solutions. It's either 2 or 4, right? Complex solutions always come in pairs. It's always plus or minus, plus or minus, plus or minus. Okay? All right? So, for that reason, like, you know, you can get one real root, but you can never get one complex root. It's always 2 or 4 or 6 or 8. Okay? Yeah.
For like the, can you go up where it says like the like b squared?
Uh-huh.
Like how are they not the same thing? How is one a perfect square and one's not?
Oh, like here, for example, take a look at this one. So like, take a look at these. B squared minus 4ac, here I got 100, which is a perfect square. So my answers were nice and rational, right? So look at this one. Look at this one. It's positive, but it's not a perfect square. And my answer was 4 plus or minus root 7. This is an irrational answer. It's not like 3 and 5 over 2. You see that? So if it's not a perfect square, it'll stay in the root. It'll be irrational. Yeah.
For the last type where it's like the discriminant is less than 0, I'm a little bit confused with like complex roots.
If the discriminant is negative, you get a negative inside the root. So you get like the square root of negative 36, right? In which case, it has to be 6i. So you get imaginary number, not real number. Okay? Yeah, last one and then I
Just run back to the chart for a second. I just want to see if it says the last one is 2 complex irrational roots or just 2 complex.
No, there can be complex irrationals, just 2 complex roots. Yeah. Okay, so here it says to find the value of the discriminant, right? And there is not a symbol for discriminant, so we're just going to find it. So the discriminant is b squared minus 4ac, right? This is going to be 64 minus 4 times a times c. And that will be 64 minus 20, 44. So that's the discriminant. Then describe the number and type of roots. Okay, so it's positive, which means 2 real, right? Is it perfect square? No. So it's 2 real irrational roots. So 2 real irrational roots. Okay, here, the discriminant is b squared, so 121 minus 4 times 7 times 5. This is 121 minus how much? 140. So it's negative. It's negative 19. And if it's negative, how many roots do I get? 2 complex roots. Okay? Yay. Yay. Okay. All right. So you can go ahead and start the homework. Okay.